Welcome to another module in ESTCP's series on advanced lighting controls. This module is on LiTES, the Lighting Technology Energy Solutions from the Department of Energy. In this webinar, we'll look at a case study, which is the Lighting Technology Energy Solutions from the Department of Energy. We look at the problem identified by DOE. Then we go over the perceived solution. We'll look at the savings potential expected from advanced lighting controls. Looking at the demonstration, we'll see the project objective, go into the demonstration, review the benefits and barriers to advanced lighting controls adoption. This webinar will give you an overview of the Department of Energy's program on advanced lighting controls. LiTES was a 3-year program from the Department of Energy's Office of Energy Efficiency and Renewable Energy. The program, which ended in 2019, looked to reduce the energy use in small and medium commercial buildings by greater introduction of advanced lighting controls. Studies showed lighting was more than 16% of electricity use in small and medium commercial buildings. The DOE saw a low adoption of the promising technology in advanced lighting controls. The DOE also saw studies noting that introduction of LEDs coupled with advanced lighting controls could lead to energy savings of 30%. The solution that DOE saw was a goal to study the impact of the use of advanced lighting controls with the LiTES program. It saw an opportunity to make an impact through advanced lighting control adoption in small and medium-sized commercial buildings. The audience was building owners, building managers, contractors, installers, manufacturers of advanced lighting controls, designers and architects, and finance professionals. The Design LiTES Consortium, who provided some training sessions during LiTES, found there to be great potential for energy savings if LEDs and networked lighting controls were adopted into commercial and industrial buildings. Here we see from a DLC 2018 study the potential to save 78 terawatt hours from installation of networked lighting controls. The objectives of the program were to train contractors on advanced lighting controls and systems, deploy advanced lighting controls demonstrations at 10 small or medium-sized commercial buildings, conduct measurement and verification at sites to help utilities determine appropriate incentives for connected lighting systems. NextEnergy, the prime contractor, collaborated with DTE Energy, Consumers Energy, the International Brotherhood of Electrical Workers, Local 58, the National Electrical Contractors Association, and the Michigan Advanced Lighting Controls Program. On this program, training modules and sessions were developed with the collaborators. And as a result of this training, 300 professionals were trained on advanced lighting controls. Through the LiTES training sessions, more than 300 professionals were trained on advanced lighting controls. Sessions were held by the Michigan Advanced Lighting Controls Training Program and with assistance of Design LiTES Consortium trainers. Half-day sessions were held for the utilities trade allies. Shorter 2-hour sessions were held for commercial lighting designers. And a LiTES Summit was held, where training and case studies were presented to architects, lighting designers, and engineers, contractors, and environmental professionals. Utility incentives. Guidelines were set to be considered for utility incentives. The facility must be commercial building less than 100,000 square feet. Simple payback from installation of advanced lighting controls must be less than 8 years. Energy savings must be reported to the utility. The advanced lighting controls must meet 3 of the Design Light Consortium capability requirements. And to qualify, the electrician or electrical contractor installing the advanced lighting controls must attend a LiTES training session. Incentives were determined by the utilities. Survey questions were developed by the team. The DOE reviewed and agreed to the questions. A survey tool was created. The utilities sent out surveys and interviewed potential small and medium commercial building customers. When all was said and done, TTE offered 12 cents per kilowatt hour saved, and Consumers Energy offered 25 cents per kilowatt hour saved as incentives. Demonstration portion of LiTES aimed to deploy and collect information from actual sites. 10 sites were identified for measurement and verification. Baseline energy use was verified and recorded. New advanced lighting controls were installed at the 10 sites. Note that the goal was to determine savings from installation of advanced lighting controls, not from the installation of LED lighting. So baseline energy use was noted prior to commissioning advanced lighting controls, regardless of whether or not LEDs were installed. Installations of lighting controls had to meet ASHRAE 90.1 standards. Those standards being occupancy sensing, lighting density, and others of 90.1. Controls activated must be at least 3 of the DLC noted capabilities. So they must install 3 of either daylight harvesting, high-end trim, zoning, occupancy sensing, continuous dimming, addressability of devices, or networking of devices. From that demonstration, we have the results from the 10 measurement and verification sites. The building types were education, office, manufacturing, and office training. As you can see, the manufacturing facilities had the greatest energy savings. Average energy savings for all building types was 29%. The team surveyed the utilities and customers at the participating sites. The benefits they saw from installing advanced lighting control were energy savings, lower installation and operating costs, lower impact to the environment and reduced carbon emissions, brand attribution. The utility was seen as a customer education resource to help customers set and reach their own goals. Increased customer satisfaction, better control of lighting, such as dimming versus simply on and off, helping to meet broader utility incentive portfolio programs, and the increased likelihood of incorporating small and medium commercial buildings into utility demand response programs. The perceived barriers to adoption of advanced lighting controls were lack of awareness or education on advanced lighting controls and networked lighting controls, technologies for customers and trade allies, lack of customer trust and contractor energy savings reported, challenges integrating advanced lighting controls and networked lighting control systems with customers' IT security protocols. System pricing varies significantly by manufacturer and to some extent contractor market. Technology issues and interoperability of advanced lighting controls and network lighting control systems with existing building systems. Brand differentiation and customer confusion on advanced lighting controls and network lighting control technologies and system capabilities. And they all need to be careful to not overinvest in underperforming areas of the utility incentive portfolio. And wondering, is this what we mean by brand differentiation? So the key findings of the LiTES program regarding advanced lighting controls were energy savings, avoided emissions, and resources were needed. For energy savings, advanced lighting controls and network lighting controls were shown to reduce energy use an average of 29% in small to medium commercial buildings. Measurement and verification sites, net energy savings of 515,000 kilowatt hours, which corresponded to greenhouse gas emission reductions of 299 metric tons of carbon dioxide. And for resources needed, we saw that there needed to be market education and utility incentives, which are still necessary to break down barriers and increase the adoption of advanced lighting controls and network lighting controls in small to medium commercial buildings. Thank you for viewing this latest module on advanced lighting controls from ESTCP. We look forward to seeing you on future modules. Thank you.